Here's the video on decimals, and this is video number 17. Let's continue here. Let's look at outline here. We have decimal number, that's the first section. Then we have add, subtract decimal numbers, a section on that. Another section on multiply and divide decimal numbers. We will discuss decimal numbers and basic operations on decimal numbers. Let us continue. So what is a decimal number? Let us see if we can figure out what decimal number is. First of all, what's decimal number? It is a number in decimal, which is 10 base. 10 base means digits 0 through 9. Number system. If a fraction, it's a fraction, usually a mixed fraction. Mixed fraction means has a whole part and fractional part. Okay, let's continue here. A numeric expression, which is like a monomial of one term. It's just like in algebra, there are monomials. This is just like a monomial, a numeric expression, and has only one term. Okay, it doesn't. Okay, let's continue. Of three parts, whole number, fraction, and separator. So would have a whole number, fraction, and separator. Separator is the decimal point. Okay? Is coefficient and exponent. Just like in algebra, we have a coefficient and exponent, which is power of x. Here exponent would be power of 10. Let's continue here. So example, 29.163 is a decimal number. It has a whole part, it's a fractional part, and a separator, which is decimal point. Okay, how about 69? It sure is a decimal number. It's within the 10 base system, has 6 and 9 from 0 through 9, and with the implied fractional value of 0. If fractional value is not specified, its implied value is 0, which is a dot 0. Okay, let's continue. So this 29.163 is a decimal number, and so is a 69 with a 0 fractional value. 0 as a fraction. Okay, let's see where decimal numbers come from. Okay, where did decimal number come from? Okay, as a fraction, it must come from division, and we have a video on fractions here. So this come, and this is the division here. Dividend is divided by divisor, and answer is quotient with the remainder at the end. Okay, let's continue here. So how is decimal fraction different from a count fraction? So in a count fraction, we did the division here, and then we say we had a quotient and a remainder. Okay, and the answer. So and fraction was equal to quotient with the remainder as a whole part, a remainder divided by divisor as a fractional part. If a whole part was 0, then it was a pure fraction, and if whole part was not 0, then it was a mixed fraction. If remainder was 0, it was a whole number. Okay, let us continue here. So divisor is a natural base number. What difference is that divisor in the fraction was any number we can think of, and here divisor is a natural base number. Those are numbers like 1, 10, 100, 1000, and on fractional side is a 0.1, 0.01, 0.001. Decimal numbers and count fraction. Let's try to compare them. Okay? How is decimal fraction different from common fraction? Okay? And divisor is natural base number. That's what we studied in the previous slide. Okay? Have you divided by natural base number? So we would have to divide by natural base number. Okay, and in fraction we were dividing by the divisor. Here divisor is a natural base number, and have you divided by natural base number? Okay. Sure, you have done that before. In 3 methods of division we discussed before, we use 2-step division. Example, here's one example, nickel method of division. So we first divided by the base number and then by proportionality and made adjustments. Okay, steps were divide by base number, divide by proportionality, and adjust. Okay, that's what we all 3 methods here discussed in division. This is one of the example is, and this is what we did: divide by base number, then divide by proportionality, and adjust. Okay, adjust for what our deviation is. Let's continue. Do you recall how did we divide the base number? So you recall how to we divided by base number? Let's divide by base number, okay? You do you recall how we did divide by base number? Okay, continue here. Let's say the number was 538414. We are dividing by 1000. 1000 is a base number. What we did? We draw a line to the left of a 3 digit. 3 digits come from number of zeros in the base number. Okay, and we said that if you were dividing 538414 by 1000, then 538 was the quotient and 414 was the remainder. And also 538 is the whole number and 414 is the decimal fraction with the whole number. So this would be a mixed fraction, 538 as a whole number and 0.414 as a fraction. Okay, so we dividing by 1000, which is base number, is moving the decimal point from the implied position of rightmost position to 3 position to the left. So move the decimal point from the implied position of the rightmost position to the 3 positions to the left. Okay, so that's how we divided by base number 1000. Let's continue here. So that's 538.414. Okay. But that means 538.414 is 538.414 divided by 1000. We got 538.414 we got from here. So that's what it is. Okay. And 1000 is 10 times 10 times 10, which is a 1 times power 10 raised to the power 3 or 10 cubed. Okay, so in the denominator. So that is equal to, if you say that in the numerator is 538414 times 1, which is a 10 power 0 divided by 1 times 10 power 3. Okay, then that's x to 0. Just like in algebra, that's like x power 0 and 1 times x cubed. Okay, where x is equal to 10. Okay, let's continue here. So that we did say that we're going to divide the coefficients in here in algebra video. 538.414 divided by 1, which is 538.414, and we subtracted the flag values. Flag is 3 here, flag is 0. 0, 0 minus 3. Flag in the numerator is 0 and flag in the denominator is 3. We subtracted the flag of the numerator. From the flag of numerator, we subtracted the flag of the denominator. 0 minus 3. So the result was, okay, so that's it of the form coefficient times the exponent. This is the coefficient part and this is the exponent part. Okay, and decimal number is similar to an algebraic expression. This is, okay, so decimal number is similar to an algebraic expression. It's a, in algebra there are monomial, binomials, trinomials, etc., and polynomials, and a number decimal number is a monomial. Okay, let's continue here. Decimal number is a numeric expression. Okay. So instead of algebraic expression, this let's see if we can add zeros to the decimal number. Okay, how you added zeros to the right of decimal number? Do you remember that? Answer: you should have done that and have done that without a second thought. It was in divisions when we were decimalizing the results. When we were decimalizing the results, we kept adding zeros to the right and didn't even think about it. Okay, let's continue here. Example: in nickel method division, we computed 1 over 13 via 3 divided by 39. We continued dividing past 0. Okay, and by adding zeros, okay, because 1 divided by 13 was 0 and the remainder was 1. Okay, let's continue here. Question: does that change the value of decimal number? When we add zeros to the right of decimal, does that change the value? Question: what does adding a 0 to the right accomplish? If you did add a 0 to the right of the number, what happens? Answer: it multiplies the number by 10. When you add a 0 to the right of a number, that multiplies the number by 10. Okay, let's continue here. How do you keep number from changing its value and still add zeros to the right? Now we want to add a 0 to the right and still keep the value same, which is equivalent value. Okay, let's continue here. How do you do that? If you simultaneously divide by 10 also, then you would have achieved that kept the integrative number and still added a 0 to the right. Okay. So let's say consider number 25.12. Okay. So we want to add a 0, and this 25.12 is like 2512 divided by 1000, which is like 2512 times in the numerator 10 power 0, and in the denominator divided by 10 squared. Okay, let's continue here. So that's like 2512 times 10 power minus 2. We subtracted the flag values 0 minus 2. Okay. 2512 divided by 1, denominator had a 1 times, and so which divided the coefficients of the numerator by that of the denominator and subtracted the flag value of the denominator from the flag value of the numerator. Okay. So that is equal to, now we're going to multiply and divide by 10. Multiply by 10 in the numerator and multiply by 10 in the denominator. Okay. That's equal to, which is equal to 25120 divided by 1000. Okay. So we took the number here, we multiply by 10. Okay. And that's like 25. When you divide by 1000, it's like moving the decimal point from the implied position to the rightmost to 3 position to the left. There are 3 zeros in 1000, okay, which equals 25.120. We just added a 0 and we still have the same equivalent number. In 25.12, we added a 0 to the right. We achieved that by multiplying and dividing by 10. So that means we did not change the value. It's equivalent value. So 25.12 is equivalent to 25.120. That means we can add zeros to the right of decimal point. Okay. If the decimal point wasn't here, we couldn't add a 0 without changing value. But if decimal point is here, we can keep adding zeros to the right. It does not change the value because that implies multiplying and dividing by 10. Okay. Let's continue here. So that's equal to 25120, like just like the same one, 1000. Okay. And that's equal to 25120 times 10 raised to the power minus 3, which is a coefficient is 25120 and exponent is 10 to the power minus 3. Okay. You have minus 2 here, now the minus 3 here, the 2512 here, and 25120 here. Multiply this thing by 10, 25120 coefficient going to multiply, and also divided by 10 by subtracting a flag value from here, 10 power minus 2 and 10 power minus 3. Let's continue here. By adding it to the right, we reduce the exponent power of 10 by 1. We reduce the exponent power and we added a 0. Okay. Let's continue. By adding 0 to the right, we can change the exponent or the flag value. So we just, when we add the 0 to the right, we are changing the flag value. Okay, let's continue to the next section here. Okay. So it's a decimal. We all talked about decimal numbers, what those are. Now we are going to talk about how to add and subtract decimal numbers, and in the following section we will discuss multiply and divide decimal numbers. Let's continue. Okay, let's recall some observations from so far in the previous section. Okay, let's recap the previous section here. Okay. A decimal number has actual or implied decimal points. So there is a decimal point, either it actually exists or it's implied. There are digits to the left and the digits to the right of that point. For a pure fraction, we usually use a 0 to the left of the point. For a whole number, there is an implied point and a 0 after that. Okay? A decimal number results from division by a natural base number. Okay? Decimal number is a fraction, usually a mixed fraction, and comes from division just like the common fractions do. Let's continue. A whole number comes from a division by 1. A decimal number can be represented by coefficient and exponent. That's we studied already, where coefficient is a whole number and exponent is a power of 10. where 10 is a base number. Further, power of exponent is negative of number of digits to the right of decimal point. Okay, power of the exponent is negative of the number of digits to the right of the decimal point. Okay, let us continue. Let's continue with the recap here. This is what we already studied before. A decimal number can be represented by coefficient times the exponent, where coefficient is a whole number and exponent is a power of 10, where 10 is a base number. Further, power of the exponent is negative of the number of digits to the right of decimal point. Okay. Let's continue here. We can add zeros to the right of a number with the embedded decimal point. Okay. If a number had an embedded decimal point, we can add zeros to the right of that number without affecting the value. Okay. By adding zeros to the right of such a number gives me another number which is equivalent. Okay. And we obtain that we add zeros, that implies that we are doing the multiply and divide by 10. Okay. When we add a zero to the right of a number containing decimal point, then we are multiplying and dividing by 10. Okay, so that means we are getting an equivalent number. That multiplies the coefficient by 10 and subtracts 1 from the power of the exponent. Okay, so that would multiply the coefficient by 10 and subtract 1 from the power of the exponent. Let's consider some operations with decimal numbers. Add, subtract. In a video on algebra, and this is the video, we had argued that if flags match, we can add, subtract. We can add, subtract the coefficients. Okay? In that case, we perform the operation on the coefficients. Okay? So add and subtract we performed on the coefficients. Let's continue. So let's do example. 5003,436 plus 2140902. Okay. Okay. So I can do a number splitting here to make it easier. Okay, we split the number in here, 2 digits, 2 digits, 3 digits, 2 digits, 2 digits, 3 digits. Okay. Then we say 500 plus 214 is 714, 34 plus 9 is 43, 36 plus 2 is 30. So add these numbers together and I got 7144338. Okay, let's continue here. Question: which decimal point in the example? We were looking for decimal point. Is the decimal point in here? Okay. Answer: there is one, an implied decimal point, and 0 to the right of the whole number. This is a decimal number with the implied decimal point after the 6 and a 0 after that. This is a decimal number with the implied decimal point after the 902 and 0 after that. Okay, let's continue. So now we'll talk about adding decimal numbers. Okay, so how would we treat number with actual decimal point? Okay, let's see, consider. Let's add these numbers together. Consider 89236 decimal 70 plus 8052 decimal 23. Okay. Here, this is 89236 decimal 70 is equal to 8923670 times negative 2 second power of 10. Okay, and this number is 80522380522 times negative second power of 10, negative second power 10. And this is my exponent form of the decimal numbers we had. We studied the exponent form in the previous section. Okay? Let's continue here. So it's just like algebra here. Flags match, both flags are -2 here, and this is the coefficient 8923670, and this is another coefficient 805223. So it's like we add the coefficients like we studied in algebra video, and we kept the flags here. Flag was, exponent value was 10 raised to power -2. Okay, so again we can add them up using our number splitting again. 70 plus 23 is 93. 52 plus 35 is 87, and 892 plus 80 is 972. Okay? So let's go 972, 87, 93, and exponent is still the same, 10 raised to the power minus 2. Let's continue, and that is 97287.93. Okay? It's like 97287.93 divided by 100, and when you divide by 100, decimal point just come in here, the 2 digits to the left of rightmost digit. Let us continue here. What did we do here? We first converted the exponent form. From there, we applied lesson from video on algebra. Okay? And that lesson was if flags, which is power of the exponent, this one, and this one, match, we can add the coefficient, which just we did. Okay? Let's add numbers again. Do we have to convert to an exponent form? Question. Answer, no, you can add decimal numbers directly. Do we need to watch for anything? If we were going to add them up without converting to exponent form, what is there something we need to be careful of? Okay. Yes, before adding, subtracting, you need to ensure that the flags do match. Okay. So let's look in here. It's a 20736.56 plus 79698.36. Flag value is minus 2 for this monomial, this term, and also for this second term. One operand has flag value minus 2. There are 2 digits to the right of the decimal point, and the other one also has a flag value of minus 2. Flags do match. Okay. Now we can just add them up. 20736.56 plus 79698 decimal 36, and so 56 plus 36 is 92, 36 plus 98 is 134, 7 plus 6 is 13, 14. So we have 79 plus 20 is 99 plus a carry 100. So we get 100434.92. Okay. So when the flags did match, we didn't have to convert. We just say add the numbers together and kept the decimal in the same place where it was in the operands being added. Okay. Let us continue here. Okay. So this is what we did in previous on previous slide. Okay. What did we do? Verify that flags match. We did say minus 2 here and minus 2 here. Okay. Add it as if we were dealing with whole number. We just didn't, during adding, we just didn't care for the decimal being there. We just added as if there are whole numbers only. Okay. And after that, kept the position of the decimal point. Decimal point was to the 2 digits to the left of the rightmost digit, and that's we kept that. That's my flag value. Let's go do this example here. What did we do now? Verify the flag match. That's what that's added as if it were dealing with the whole numbers and kept the position of the decimal point, which is a flag value. Okay, now we're going to do this example here. Let's say flag value is minus 1 of the first operand and minus 2 of the second operand. Let's continue here. So 80522 decimal 3 plus 36331 decimal 43. Okay. Now can we add just like the previous example? Okay. Flags do not match, so we cannot easily add the numbers together. Okay. Do we see any problem? What are the flag values? Minus 1 for the first operand and minus 2 for the second operand. For the first operand, flag value is minus 1, and for second operand, it is minus 2. We cannot add the coefficient as if they are like we did in previous example. So we have to make some adjustments. We cannot straightforward add these numbers together because the flags do not match. Okay. Let's continue here. So this is our example here. So this is what we're asking. Can we add just like the previous example? Answer, do you see any problem? Okay. So there are -1 and -2 flag values. So we cannot add the coefficient just like we did in the previous example, but we still have to add them. Okay. How can we match the flag value? Do you remember what we did in the previous section? We were able to change the flag values. Okay. By multiplying and dividing by 10 repeatedly if necessary. Okay. Flag value is -1 here and -2 in the second operand. So for first operand, we'll multiply and divide by 10 repeatedly if necessary until we get a flag value of -2. Let's continue here. We can do that easily by adding zeros to the right of the decimal point. Okay. First, we know that if we add a zero to the decimal right of points, its a value doesn't change, but its a flag value does. Okay. It's equivalent value, equivalent number, but a flag value does change. That's what we studied in the previous section. So now we're going to add a 0 here, and so we've got 80522 dot decimal 30, 80522 decimal 30, and now I am flags value match. -2 for the first operand and -2 for the second operand. Now we can add. Okay, so 8 plus 3 is 11, 5 plus 63 is 68, 22 plus 31 is 53, and 30 plus 43 is 73. Okay, so that is equal to 116853 decimal 73. Okay, we started with example where flags didn't match. We made them match by adding a 0 to the right of the first number. Okay, and then we can add. Let's look at another example. 7955 decimal 423 plus 3866 decimal 13. Flag value of second operand is -2 and the flag value of the first operand is -3. So flags do not match. We have to make them match. And what we do is we add a 0 to the right. This new number is equivalent to the first number, initial number, but this one has a flag value of -3. First number also has a flag value -3. Now we can add. Okay, 79 plus 38 is 107 and 55 plus 66 is 121. 1 gets carried to the left. On the right side, 423 plus 130 is 553. Continue here. So that's after we resolve this carry here, the number becomes 108 21 decimal 553. So that's equal to 10821 decimal 553. Let's continue here. Okay, another example here. 6177 decimal 126 plus 4360 decimal 527. Flag values match here. -3 is for the first operand and -3 is for the second operand. Let us continue here. So when we add them together, it's with number splitting again. 61 plus 43 is 104 and 77 plus 60 is 137 and 126 plus 527 is 653. Let's continue here. So that's equal to 104 here, 137 here, and 653 here. 26 plus 27 is 53, 1 plus 5 is 6, 77 plus 60 is 137, 1 gets carried, 61 plus 43 is 104. Let's continue here. After we resolve the carry, it's a 10537 decimal 653. We added these two numbers together. Flags matched 6177 decimal 126 plus 4360 decimal 527, and the answer is 10537 decimal 653. Let's continue. Observations. We align the decimal points. So what we did is we align the decimal points here. Okay, added zeros to the right for convenience. When there is a need to, when the flags do not match, we add zeros to the right, and that's just for convenience. As soon as you align the decimal points, we basically have a matching flag. Added the operands and kept decimal point. Okay, so that's what we did. Take this number together, press this number, add 0 to the right, so that there are 3 digits to the right of decimal here and 3 digits to the right of decimal point here. Adding a 0 to the right of a number containing decimal point is an equivalent value, and it comes from multiplication and division by 10. Okay, then we can add them together as if uh, they were just whole numbers, but we need to keep track of the decimal point where it is and keep it decimal point same place. Same thing here. Now, the digits to the right of decimal point is 3 here and 3 here. Flag value is minus 3 here and minus 3 here match. We can add. If they didn't match, we like in here, we just align the decimal point and add 0 for convenience and add the operands and kept decimal point just in this example here. Let us continue and do a subtraction using decimal numbers. Okay, let's continue here. Question: how do we subtract decimal numbers? Okay. Answer: we have already learned that we treat decimal number like a whole number with decimal point. Okay. For addition, if we align decimal points, we can add the two numbers. In algebra video, we learned that we can add and subtract the monomials, which is single term, if the flags match. So this is we are using that lesson from algebra. Okay. If decimal numbers, in decimal number we do have exponents which and flags. Okay. Exponents have flags. Okay. Let's continue here. We match the flags by aligning decimal points. Okay. We match for addition and subtraction. We match the flag by aligning the decimal point. Let's do examples for subtraction. Here this is example. We have 66546 decimal point 73 minus second operand is 45498 decimal point and a 3. There are 2 digits to the right of the decimal on the first number, and there's only 1 digit to the right in the second number. Okay. Continue. So minus 2 is the flag here and minus 1 is the flag. Now we add a 0 to the right. Now there are 2 decimal positions after decimal here and 2 after decimal in first number. So flag values now do match. Now we can subtract. So 66 minus 45 is 21. 546 minus 498 is 048. And 73 minus 30 is 43. Let's continue here. It's 21048 decimal 43. Let's continue. Example: 85721 decimal 08, and we're going to subtract 20802 decimal 31. Now we can subtract. We say 8 minus 2 is 6, 5 minus 0 is 5, 7 minus 8 is negative 1, 2 minus 0 is 2, 1 minus 2 is negative 1, and 0 minus 3 is negative 3, and 8 minus 1 is 7. Now we have negative number here and negative here and negative here. Okay, let's resolve the negative numbers and see what comes up. So first of all, 51 here, 5 positive and 1 negative is 50 minus 1, which is 49. So 649. A 2 here positive and a negative 1 and negative 3. These three numbers together make it a 200 minus 13. That is 187. So 18 decimal 77. Okay. So 85721 decimal 08 minus 2082802 decimal 31 is 64918 decimal point 77. Okay. Let us continue here. Observations. We align decimal point. We just aligned here. Okay. We align here. Okay. Right here, line decimal point here. Okay, aligned here. Add zeros to the right of for convenience. We added 0 here for convenience here. Add the operands. Subtracted the operands here. So we are doing subtraction, so we subtracted the operands and kept the decimal point. Okay? We subtracted the operands and kept the decimal point. You can do some exercise here. Some add 7907 decimal point 417 plus 28193 decimal 36. Okay, let's continue here. 34890 decimal 09 plus 19495 decimal 25 and some more. Okay, now we're going to subtract something which is 1882 decimal 869 minus 62 decimal 6843. Let's continue. 75432 decimal 89 minus 45309 decimal point and 10 and some more. Okay, let's continue with the next section here. We have covered decimal numbers, what net decimal numbers are. We also gone through add and subtract using decimal numbers. Now in this section we discuss multiply and divide decimal numbers. Let us continue here. Decimal multiplication. Okay, that's the first thing we do. From algebra video we know that to multiply we do what? Multiply the coefficients and add the flag values. Okay? We'll do the same in decimal multiplications. Let's continue here. We do the same in multiplying the decimal numbers. Okay, because decimal numbers are product of coefficients and exponents. Let's continue. How do we add flag values? We just add the number of digits to the right of decimal. It's very easy. And in the decimal number, and flag value is negative of the number of digits to the right of the decimal number point. Example 0.25 times 0.25. There are 2 digits to the right in here and 2 digits to the right in here. When we add 2 plus 2, we get 4 digits to the right. We know that 25 times 25 is 625. We have to have 4 digits to the right and we add a 0 to the left. If you add a 0 to the right, that's not 25 times 0.25 times root 2, 0.25. Okay. So it's 0.0625. We know that 25 times 25 is 625, which is by one more than one before when we were drawing proportional base multiplication. We did that using it's a numbers ending in 5, square of the numbers, and we say that's on the left is 2 times 3, which is right here, on right 25. However, we need 4 digits to the right of the decimal point, so we need 0 to the left of the 625 here. Let's continue with the multiplications here. We already did 0.25 times 0.25 is 0.0625. Okay. Note that some student might answer it to be like 0.625 or 0.26250. Both will be wrong and they both represent the same value, 0.625. Okay, let's continue here. Okay, so let's consider 0.25 times 0.25 is 25 by 100. We got a 0.25 from dividing 25 by base number 100. Okay, let's continue here. So that would be 25 times 25 in the numerator, 25 from here, 25 from here. And the denominator we have 100 times 100, which would be 625 divided by 10,000. Okay, and that is 0.0625. Okay, if we did convert that into a fractions before you multiply, we get in 0.0625. Okay, and also we can say 0.25 times 0.25 is, it's a coefficient an exponent, a coefficient, and an exponent. We multiply coefficient 25 times 25, 625. Add the flag values in the exponents, minus 2 and minus 2 plus, when you add minus 2 to minus 2, again minus 4. Okay? And which is again 0.0625. It's not 0.6250, instead it is 0.0625. So 0.25 times 0.25 is 0.0625, just like we got before, just like in here and in here. Okay? Let's continue. Let's do an example. We're going to do 81.2 times 2.485. Okay? So what that we got? A flag value of the result is minus 1 from here and minus 2 from the second operand, minus 3. Okay. Number of digits to the right decimal must be 3. Number of digits of the product to the right of the decimal point is 3. Okay. So it's 81.2 times 2.45 is 812 times negative first power of 10 times 245 times 10 to the power negative 2. Let's continue here. Which 812 times 245 times 10 to the negative third power. Okay, let's continue here. Use vertically and crosswise to multiply 812 times 214. Okay. So here it is. First digit on the unit place is 5 times 2, 10. Use 0 and carry 1. Tens place is crosswise and crosswise add. So 1 times 5 is 5, 2 times 4 is 8. And add them together 13 and plus 1, 14. So we would use 4 and carry 1. Hundreds place is that product plus that product plus that product. Okay? 8 times 5 is 40 plus 1 times 4 is 44 plus 2 times 2, 48 plus the carry 49. Okay? So we have 49 and so carry 4, okay? Keep 9. Okay? Let's continue here. 10,000 place is these two numbers crosswise. 8 times 4 plus 1 times 2. That's it. 34 plus 4. That's 38. We'll use 8 and carry 3. Let's continue here. 100th place is this number. 8 times 2, 6 vertically, plus this carry 3 is 19. Okay? And we're done with it, so there are no carries. We just say 19 here. So result is 812 times 245 is 198, 198,940 and a 0. 198,940. Okay, and we say 81 decimal 2 times 2-45 is that number with decimal in it before the 9. 198 decimal 940. Let us continue here. Continue with the multiplications example. So 81.2 times 2.45. We already did it. First we did 812 times 214, which was 245, which was 198,940. Then we say number of digits to the right of decimals after result is 3 here. So we say 81.2 times 2.45 must be 198 decimal 940. Okay, 198 decimal point 940. Let's go make some observation. We multiplied as if the operands were whole numbers. We multiplied as if they were whole numbers and adjusted the position of decimal point later. Okay, after we got done multiplication, we say we got 1 digit to the right here, 2 digits to the right here, and 3 digits in the answer. Let's go with division now. Again, from algebra video, we divide what we do. Divide the coefficients and subtract the flag values. In the multiplications, we multiply the coefficient and add the flag values. In division, we divide the coefficients and subtract the flag value. We subtract the flag value of the denominator from that of the numerator. Let's continue here. We'll use same lessons here. Example 552 decimal 32 divided by 61.5. Flag value of the numerator is -2 and of the denominator is -1. So -2 and minus 1 is -1. So in the end, from division of 552.32 and divided by 61.5, I'll get one position to the right of decimal point. Okay, that's just because of the flag values here. Okay, so flag value of 552.32, the numerator is -2 and that of the denominator is -1. So flag value of result because of decimal point is, this position of decimal point is -1. Okay, and then division might give you some. Now we'll try to divide further. 552.32 divided by 61.5 is, you can do that, 55232 times negative second power of 10 divided by 615 times negative first power of 10. So let's continue with the remainder. Okay, so that is this division of coefficient 55232 divided by 615 and negative first power of the base number 10. Note, we already know how to solve, we know how to do these divisions here. Division of 55232 by 6115, and that's what we will solve first. And we know that exponent part, because of this number being divided, is 10 minus 1, negative first power of 10. Let's continue. So we know the 615, we're going to divide that in two parts, divide by part and adjust for parts. Okay, so we divide 600, which is 100 times 6. Okay, and thus 15 will go on the flag. Okay, further we'll decimalize it. So we have decimal numbers here, and now with the decimal point here, and we know this is the decimal point representation, and we will decimalize the results. Okay, we just won't say the quotient is such and such, remainder is such and such. We'll say quotient is such and such, remainder is such and such decimal fraction. Let us continue here. Okay, so this is what we know already. We also said 615 is 600 plus 15. We'll divide by 600, which is 100 times 6, and adjust for 15, and 15 will go on the flag. Setup problem is 15 on flag, and 6 as for divisor. We'll divide by 6 and get back to 15 later. Okay? Okay? So first we divide by 100, my first divisor. This is how I do that. Okay? This also separates the quotient section from the remainder section, and also in this section sometimes we have a decimal fraction we get. Okay? Sometimes we get a remainder on the right side, and sometimes we get a decimal fraction. In this case, we will get a decimal fraction here on the right. So now start by divide by 6. 55 divided by 6 is 9, remainder 1. 9 goes quotient, 1 as a remainder. We prepend the remainder 1 to the next digit, so we get 12 as a next cross dividend. Okay, and then we will start to adjust them because of, and we use a vertical and crosswise. So far I know 15 is my flag digits here, and only have one quotient digit. Okay, so 5 won't play out in here. Only players are 1 and 9. Okay? Okay? So gross dividend is 12, net dividend is 12 minus 9. 9 times 1 is 3 here, which is 3. Okay? Continue here. Then we have a 3 here. We just got a 3 in the remainder here. We divide 3 by 6, you get 0, remainder 3. Okay? So that gets 0, and a decimal place here, and 3 is the remainder for the next division. So with this setup here, we already have 2 digits of the quotients, and decimal point goes in the line here, on the line here. Okay, okay, and then we have two quotient digits 9 and 0. We can use both of the digits on the flag, 1 and 5. Gross dividend is 33, this one here, and net is 33 minus 45, which is 1 times 0 is 0, and 5 times 9 is 45. So it's we're going to subtract 45, which is minus 12, and then we'll divide that by 6. Then divide minus 12 by 16, it's a minus 2, remainder 0. Okay, that gives me minus 2 on the quotient line and 0 on the remainder line. Then on the next step, we have both digits are from the flag, and the most recent 2 digits of the quotient are 0 and a negative 2. Gross dividend is 2, and net dividend is this is minus 2. We can subtract minus 2 from 2, which will become 2 plus 2, which is 4. Now 4 divided by 6, there's 6 right here. We got 4 in here, 0, remainder 4. Okay? That gave me 4 as a remainder and 0 on the quotient line, 4 as a remainder. Okay? Let's continue with the division here. We are done so far. Okay? Now, our next step will be using negative 2 and 0 as the most recent quotient digits, 1, 5 as the from the flag digits. Okay, gross dividend is 40 here. Net dividend is 40 plus 10. I got 1 times 0 is 0. 5 times negative 2 is negative 10. When we subtract negative 10 from 40, I become 40 plus 10, which is 50. Now we divide 50 by 6. I got 8, remainder 2. Okay, so I got 8 here and a 2 remainder. 8 in quotient line and 2 in remainder here. Let's continue. Our next step, we have a 0, 8, our most recent quotient digits, and 1, 5 from flag digits. Okay. So gross dividend is 20, is 2 here. Net dividend 20 minus 8 is 12. And we divide 12 by 6. 12 by 6 is 2, remainder 0. Okay. We just stop division now. We got 4 days after decimal right now. 90.2 negative 082. Okay. That means that 55232 divided by 615 is approximately 90 decimal 2 negative 082. Okay, which is equal to 89.8082. These first 3 digits to the left comes a 900 minus 2. 900 minus 2 is 898. That's 89.8082 approximately. We stop the division here, and we didn't continue any further, so this is approximate. Let's continue with division again further. So we have done so far. We are in a, if you divide the coefficients only, I get 89.8082 approximately. Okay, let's continue here. But when we had the decimal numbers, we had would have 89.802 times negative first power of 10. Okay, so when we divide this number by 10, that comes out 8.98082. This minus 1 moves the decimal place to the 1 position to the left, from just before 8 to just before 9. 8.98082 approximately. Let's continue here. Observation, what we did, we divided as if they were whole numbers. Okay, and adjust the decimal point later. Decimal with whole number, I got 89.8082, and I had to adjust decimal point, move it 1 place to the left, so got 8.98082. Let us continue here. Let's do some exercises. So let's multiply 371.2 times 961.3, 52.08 times 75.06, and some more. Now divide 9472 decimal 6 divided by 11.7. 127.49 divided by 7.20, and some more. Okay, and the references. Okay, Vedic Math Teacher Manual, that's the volume 1. This is elementary level by Ken Williams, and the book you can obtain from vedicmaths.org. Okay. And Vedic math of Bhartiya Tirthaji. This is the main primary reference on Vedic math. Anything we do Vedic math, this is the primary reference for that. And this Ken Williams book, Discover Vedic Math by Ken Williams. This is the most complete, authoritative, and consistent notations. The book is organized by sutras. Okay, continue here. Vedic Math for Schools in 3 volumes by James T. Glover. Mr. Glover used these books in school. It's easy to read and very complete. Not as complete as Williams' book is, but this is very complete and contains significant geometry. Okay, let's continue here.